Now we come to the second part of smart cities and smart homes. In part 1, we spoke about the need for smart cities, the challenges in building smart cities, and few of the different issues with respect to building smart cities. So, in this particular lecture, again we will be focusing on smart cities, and these again, whatever we will be discussing on smart cities are also applicable for smart homes as well, but we will have a focus on smart home in another lecture. But here we are going to discuss some of the technical issues behind enabling smart cities, some of the technical issues. So, let us consider something before we go further. We have already seen that we have all these different components, the transport, railways, schools, and etc., and let us say in between we have this population. Population means the citizens, right. So, all of these things, these different components, let us say this is transport. So, transport component has different sensors, has different actuators. This is, let us say, railways also has the same. Other components, schools, hospitals, they all have different sensors and different other IOT devices which generate data, and this data has different characteristics with respect to volume. This is gigantic, huge volumes of data that each of these different components they are generating, coming at high velocities, has different different types of data, media data, multimedia data, text data, and so on and so forth. There are these different characteristics of big data, 3 V's to 5 V's to 7 V's, and this is something that we spoke about in a previous lecture already. So, I am not going to elaborate on this, but what is required is to do some good planning. So, what are you going to do with all this data? So, one possibility is that these data can be made available to the population, to the citizens, but making the data available just like that will not help. So, you have to do some processing. So, let us say that processing is also done. Then you have to fuse these data that are made available from these different sources. Let us say transportation data and healthcare data sensed from different points, made available from these different locations, has to be, these data have to be fused together in order to give better insight about different things in a smart city. So, that part is really challenging. So, one thing is to deal with this kind of data, this big data that is coming in real time, analyzing, cleaning up, processing, analyzing this kind of data in real time. This is one thing, but in addition you have to fuse the data that are cross domain, that are coming from different sources, and that is a highly challenging issue. And like this, there are different other issues in the building of smart cities. In the previous lecture we spoke about the overall idea, the philosophy behind smart cities, but then you have to make it technically made possible. It is not like you connect few sensors and then communication will be Zigbee, Wi-Fi, etc., and then you make the data available. No, that data is going to be of limited use to the corresponding users or the stakeholders. So, that is going to be of limited use. So, you have to do some better job by fusing the data together and then making that kind of fused data which has more insight, which will give more insight, that will be more useful. So, let us look ahead and see what we have for us in data fusion. So, data fusion basically you are talking about in a smart city environment, we are talking about enormous volumes of data that are produced periodically, and the challenges include making this particular type of data available, and so that the incoming large data can make more sense, and with the help of this data from these different sources, the large volumes of data from these different sources, different predictions, different analytics should be executed. So, the quality of data precision and the accuracy basically affects the quality of decision making in this kind of IoT based smart city environments. So, data fusion basically enables optimum utilization of this massively collected data from different sources across different platforms. So, multi-sensor data fusion is very important, which basically combines information from multiple sensor sources. It enhances the ability of the decision making system to include a multitude of variables prior to arriving at a decision. This is what I was telling you. So, it is not like clubbing two data together alone, but you consider the different different issues and consider the different variables that are affecting these systems, and taking all of these into account, not just the sensor data, taking all of these multitudes of variables affecting the data and affecting the system together, you come up with, you arrive at a decision and make that decision made available, not just decision, but maybe the different options, and make that decision or the different options available to the users. So, data fusion basically will help you in doing this. Inferences are drawn from multiple sensor type data, and these are typically qualitative. The inferences are qualitative, and these basically are of more insight. These are more insightful, these are more meaningful than the single sensor type data. So, these putting these different types of different types of data together and drawing some kind of arriving at some kind of intelligent decision, that is more insightful than the individual data. Information fusion generated from multiple heterogeneous sources provides for better understanding of the operational surroundings. The challenges include, we are dealing with an environment where the data has lot of imperfection due to inherent devices like sensors, etc., where there is lot of uncertainty around the environment. There are a lot of inaccuracies that can creep in. So, there is lot of inaccuracy, uncertainty in the data, and that basically leads to imperfections. Ambiguity is another. We are talking about an environment where there are data that are collected have lot of different outliers. Outlier means that there would be some data points which will be far away from the similar data points in the cluster, and there could be some missing data as well. So, ambiguity in the data can also creep in. Similarly, there can be conflicts in data that are collected from different sensors about the same thing. They might be conflicting, they might be contradicting. Alignment is like this, that it arises when the sensor data frames are converted to a singular frame prior to transmission. So, that also has to be done, so that alignment into singular frame, that is challenging. Different other trivial features, for example, processing of trivial data features may bring down the accuracy of the whole system, and these are some of the challenges that have to be worked on when you are talking about data fusion in an IoT environment. So, what are the opportunities? So, collective data is rich in information and it generates better intelligence, better insight compared to the single source data from different individual sensors. So, putting this data together will make you to get better insight. So, what is required is to optimally amalgate. Optimally amalgate means that optimally integrate the data, because the more and more you integrate, it is possible to get more insight, but at the same time, you know, that also has to be done in real time to be, you know, for that decision to be more meaningful. So optimal amalgamation of data, then enhancing the collective information content obtained from multiple low power, low precision sensors, and enabling data fuser basically enables the hiding of critical data sources and the semantics, and that is useful for military applications, for medical use cases. The different stages of data fusion include decision level, which is basically an you know, talking about an ensemble, coming up with an ensemble of decisions. Then feature level, you know, that means that the different features, you know, you fuse with respect to the different features. At the feature level, the integration is done, the fusion is done. So it is basically fusion of information prior to decision making. And pixel level is fusion of information at the imaging device level itself. Okay, so at the imaging devices, that fusion is done in the device itself. And signal level, basically fusion of information at the sensor node or within the local area network itself. The mathematical methods of data fusion include using probability based schemes such as Bayesian analysis, statistics, recursive methods, AI based schemes such as artificial neural network, machine learning algorithms, deep neural networks, convolutional neural networks, theory of evidence based you know, evidence based schemes, for example, belief functions, taking use of belief functions, transferable belief models. So these are the different mathematical methods that are used in order to come up with this intelligence from the different data that are, you know, that are secured from the different IoT devices. So AI, artificial intelligence, comes as a big helper in enabling this. So you know, let us consider this particular figure. So traditionally what happens is you have these different sensors, and the sensor data has to be transmitted over the communication medium and has to be, you know, based on that some actuation is going to happen. But how that actuation is going to be made you know, made possible? Is it from one or two of these sensors, you know, based on this sensor value you are going to actuate, or can we do something better? So for betterment, what can be done is some kind of decision making has to be done with the help of intelligence. By adding intelligence between these different sensors and the actuators, we can make things better, make things improved. So how is that made possible? With the help of artificial intelligence tools, methods, algorithms, and so on. So AI can come as a rescuer over here, and what AI can do is it can make highly accurate decision making possible between the sensors and the actuators. So let us consider the scenario of decision fusion for autonomous vehicles. So for autonomous vehicles like autonomous cars, etc., they interact a lot with the environment. You know, when there is a driverless car, for instance, they need to take help of these different sensors. They need to also communicate with you know, with the satellite, with the GPS, with the help of technologies such as, you know, LiDAR technology for obstruction, you know, for getting a map of the obstructions ahead, or the ultrasonic sensors can help in even checking some different obstructions that are ahead of them in a small scale. LiDAR can give a bigger picture, whereas ultrasonic sensors can give a small scale picture of what is ahead of the autonomous vehicle. So autonomous cars, you know, they basically are collecting different data from different sources through different technologies like LiDAR, sensor networks, you know, from satellites, through GPS, and different cameras ahead of, you know, in front of them. So all these different data of different types, as you can see, are collected and they are sent to the server. Now, you know, these data of different types, you know, individually they do not make much sense, they are of limited help, but together can these data be fused together so that the car, the autonomous car, can get some kind of decision making about how it is going to proceed, or whether it is going to turn left or right, or what it is going to do. If it sees some pedestrians in front, then what it is going to do. Like this kind of thing is made possible with the help of data fusion technology. So, all these decision making through of the data that is collected from the different sources, that is basically made possible with the help of data fusion. Smart parking. I already spoke about smart parking in the previous lecture, but let us dig into the smart parking a little bit further. Smart parking is very much an important component. Nowadays, we have smart parking solutions in different cities already started to be deployed. So, in a smart parking environment, what happens is, the user knows ahead of actually going to that particular spot, that which of the spots in the cities have free parking spots, right, which of these different parking lots have free parking spots, and then accordingly the driver can make a decision about where to go and park the car. So, smart parking basically shortens the parking search time of the drivers. So, basically searching for the different parking lots, that search time would be reduced, will be shortened, and the parking is going to be made efficient. It reduces the traffic congestion, reduces the pollution by keeping unnecessarily lingering vehicles off the road. So, so what would happen is, in a smart way, where to go and where to park. That way it is not going to happen that you are in a queue waiting for your parking, your engine is on, you are polluting the environment. So, smart parking basically also helps in reducing pollution unnecessarily in a city. It reduces the fuel consumption and costs as well, and these are all actually interlinked. So, that fuel consumption, more pollution, more costs are involved, so like these are all interlinked. Increases the urban mobility, and the shorter parking search time results in more parked time and hence more revenue. So, in a smart parking scenario, we are talking about information collection, system deployment. Rather, I would start with the system deployment. System is deployed, information is collected, and the services are disseminated to the end users. So, these are the different functional layers of smart parking. In terms of information collection, information is collected from the sensors, the individual sensors in the car, in the parking lot. There are different parking meters. The sensors are networked together, so you have the sensor network, and also the crowd sensing. Crowd sensing basically is from the crowd, from the different sensors in the mobile phones, in the smartphones for instance, you are able to collect the different data, and this data will help in decision making. So, all these data taken together and fusion of these data will help in decision making. Then we have the system deployment with respect to the software system that has to be developed, the information management of the data, the e-parking guidance system that will help in guiding the vehicle about where to go, how to go, and and parking the car there. Then the data analytics overall. So, these are the different system level deployment issues in smart parking. Service dissemination with respect to dynamic pricing, strategizing, infrastructure based information, infrastructure free information. So, infrastructure based and infrastructure free. So, infrastructure free from the different sensors, these are not connected to the regular infrastructure like Wi-Fi, etc., etc. This is infrastructure free. Infrastructure based means like from the regular internet infrastructure, from the regular city communication infrastructure like Wi-Fi and like 3G, 4G, the cellular networks and so on. These are all like the infrastructure based information, and then infrastructure free is what I just told you, with the help of sensors, ad hoc networks formed out of these different mobile devices of different users, etc. Then parking choice and vehicular activities, these all contribute to the building of services required for smart parking. In terms of information sensing in smart parking, the sensing can be done from stationary sensors or from mobile sensors. Stationary sensors, like if you are collecting the data from stationary sensors, you need large number of sensors to be deployed at different points, which will detect the presence or absence of the different vehicles, or from mobile sensors where fewer sensors would be required compared to the case of stationary sensors, and these mobile sensors, the fewer mobile sensors would collect information along the route when they go by. Energy management in smart cities, you need energy solutions. So, energy efficient solutions, it is required to lightweight the protocols, because you are dealing with a highly resource constrained environment, and at the same time energy consumption has to be reduced for reasons of greenness, environment, and so on. So, lightweight protocols are required. It is required to schedule the optimization of optimization of energy consumption, and then predictive models for energy consumption is another important thing. Then you have the cloud based approach, low power transceivers, cognitive management framework. These are the different energy efficient solutions for energy management in smart cities. Energy harvesting solutions would include taking help of these harnessing energy from these renewable sources of energy, such as sun, wind, heat, vibration, RF sources. Nowadays people are talking about harvesting energy from radio frequencies as well. So, from the RF sources, harvesting energy from sun, wind, heat, vibration, and like this, so many different types of sources of energy, ambient sources of energy are there, and how you can harness the energy from all of these different sources. Energy harvesting solutions would include dedicated energy harvesting by deploying different different sources like solar panels, etc. Deployed, pre-deployed. Energy sources are intentionally deployed near the IoT sources to power these IoT devices. So, for example, in our agricultural field, closer to the sensor node, very close to the sensor node, we have the solar panels, and these solar panels basically power the sensor nodes that we have deployed in our agricultural field, and these sensor nodes are basically deployed were developed in the Swan lab of our institute. So, the distance between the device and the source, the sensitivity of the harvesting circuit and the environment, these basically are contributors to determining the amount of energy that is harvested. So, with this we come to an end of the second part of the lecture on smart cities. Here we have mostly covered issues such as how to handle the data that is received from these different sources. We can try to make inferencing with the help of these standalone sensor data that are received, separate the individual data that are received, or is it possible to do better? It is possible to do better by fusing the data from the different sources together with the help of intelligence and so on. So, this is the end of the smart cities part 2. In the next part we are going to talk about few other different issues of building these smart environments, and there the focus will be on smart homes. Thank you.